Hello students. So let us solve one beautiful problem from TIFR 2023 B14, and this is basically from atomic physics, basically from hyperfine splitting. So in that question, that the electronic configuration of helium mass number 3 is provided. Okay, so that is given on S on 2s0 and 2p on. It's not basically the ground state. This is basically excited state. Electronic configuration is given. Okay. So the question is the number of hyperfine splitting of the state that you have to calculate. Okay. It's a very good question actually. So you know that hyperfine splitting is nothing but the interaction. The splitting is arising because interaction between total angular momentum J with nuclear spin I. Okay. So first you have to calculate that fine structure splitting to calculate hyperfine splitting. Okay. So as you have seen from here. So first of all, let us calculate that nuclear spin. So from here you can clearly notice that helium, for helium Z is 2, and mass number, from mass number it is clearly noticeable that N is on. So according to that nuclear cell model, that nuclear spin will be arising because of unpaired neutron, and that will be on is half e power on. It means that nuclear spin of this nucleus will be nothing but I equals to half. Okay. Now to calculate that hyperfine splitting, let us calculate that fine structure splitting. From here you can clearly see that orbital quantum number L for this this electron it will be 0 because it is staying at s orbit, and for second electron that L2 that will be on. It means total L that will be nothing but mod of L1 plus L2 up to L1 minus L2, and that will give only on value, that is L equals to 1. And since electron is spin half, so S1 will be half and S2 again will be half. It means that S that can take values from S1 plus S2 to mod of S1 minus S2. Okay, it means it will have two possible values, on and 0. Okay, now we'll calculate. So as you know that F, the state or total orbital quantum number, that will be nothing but mod of I plus j to I minus j. So first you have to calculate j values, and we know I. Okay, so we'll take different f for a given set of L and j, and we'll calculate that number of hyperfine splitting. Okay, so first of all we'll have s equals to 0 on possible s, that is singlet, and you will have corresponding L is on. So obviously j can take values mod of L plus S2 mod of L minus S, and that will be simply on. And as you have seen that I is how much? I is half. It means if you use this formula, mod of I plus j to I minus j, if you apply this formula, you have j equals to half, I equals, sorry, j equals to on, I equals to half. So on plus half, that will provide you 3 by 2, on by 2. So for a given set, this is representing a state arising because of spin orbit coupling or spin orbit splitting. So after hyperfine splitting, this state is further splitting into two more states. Okay, and then you have possible other state like S equals to on and L equals to on. Okay, so S equals to on and L equals to on, that will provide you j, different j. J can take values like 2, on, and 0. Okay, because mod of L plus S2 S minus S. Now if you take j equals to, for a given set of S equals to on, L equals to on, j equals to 2, this is on possible state arising because of spin orbit coupling. And after hyperfine splitting, what will happen? You'll have F equals to how much? I plus j to I minus F, I minus j, that will provide you 5 by 2 and 3 by 2. Again, if you take another possible set, S equals to on, L equals to on, and j equals to on this another possible state because of spin orbit coupling, and if you further couple with nuclear spin, and that will provide you j equals to on and I equals to half. So obviously you'll have 3 by 2 and 1 by 2. Okay, and finally you have s equals to on, l equals to on, and j equals to 0, and possible I is half again, so which implies f equals to how much? So f equals to simply half. So these are the possible states arising because of spin orbit coupling because of hyperfine splitting. Okay, so you have a single state due to spin orbit coupling. These are the possible state, and due to hyperfine coupling or nuclear that coupling of J with nuclear spin, you are getting states. How many states are possible? On 2, 3, 4, 5, 6, 7. So possible states due to hyperfine splitting is basically how many states are possible? You'll have 7 states are possible. So you have a single state after hyperfine splitting, it will be split into how many states? 7 states. So correct answer will be 7. Thank you.